All right, let's get started. Hello engineers. I sincerely apologize for starting late today's session, as many participants were also delayed. And to ensure that no valuable content is missed, the lost time will be compensated on Friday. I would like to officially welcome everyone in this today's session and appreciate your dedication and participation. I look forward to a productive learning experience together with Mr. Engineer Tejesh. So, Tejesh, it's your time to take a floor and kick off with the training. Thank you.
So I will unmute my mic. I think so. Can you mute yourself?
All right. Welcome back again. It was good to have the feedback from you guys. I really like it. Make sure you get your voices heard as best as possible. So today what we will be talking about, we'll be continuing basically where we left yesterday. Now, from the discussion we had yesterday, just wanted to get a feedback regarding the E20 spreadsheet. Did anyone have questions before we move forward in the Revit work? No questions?
Yes.
Sure.
All right. Okay, there is one point online from Tony. Okay, Tejesh, yesterday you were somehow fast towards the end. I'm requesting today, before you go any further, you first briefly explain us the general overview of the table. Brief steps of how to get inputs marked in blue. I only got to get the area and DT, the rest I didn't. The purpose of the totals at the end in the table, how can we use them to design the HVAC systems? All right. So we'll begin with that point. This is that same spreadsheet that we had filled in yesterday. And Tony, as well as the folks online, please chime in through chat as we move forward. All right. Okay. So we were talking about this spreadsheet yesterday. The spreadsheet had 2 tabs and we worked on room number 1. All right. For now, we will focus on the room number 1 only with opening our Revit model. Okay. So yesterday we had saved the Revit model. What we need to do is go ahead and click on open over here. All right. That will take you to the open window. And I want you to go to the location where you have saved that Revit model and go ahead and open. All right. So this one, go ahead and click on open over here. The same file that we had created yesterday, please go ahead and open. Again, since the architectural model is based in Revit 2018, it might take some time to upgrade it. Please bear with it. Is everyone on the open model tab right now? Yes. Please do raise your hand if you're stuck somewhere so that we can get it resolved. In the meanwhile that this is getting downloaded, you must have gotten another email from Emmanuel earlier today in the morning. Please go make sure that model, it is the updated architectural model, is downloaded on your local drive before we move forward with this step. Does everyone have the updated Revit model downloaded? Architectural Revit model downloaded on your desktop or local drive? Yes? Anyone that is facing any issues for getting this updated RCCG proposed medical center downloaded? Sorry. Yes, we will use the same MEP model. Let me announce it. So we will use this question online was, are we going to use the same MEP model? No. Is it okay? Can I go forward? Okay. Okay. So we are going to use the same Revit model that we had set up yesterday. So for that, as I mentioned, when you go to the dashboard, when you see over here, let's open another Revit. You can try. So till I show you the open ribbon, do you have rest of who have access to the model yesterday? Have you downloaded that model? Basically, have you opened that model, not downloaded that model? Just a minute. I want to show you the dashboard again to make sure you understand where to open it from. Okay, so when you are coming to the first screen over here, models open, it will take you to the open window over here, and the model that we had worked on yesterday, can you please go ahead and open that model? Is it open? Yes? All right. Can we move further? Any doubts, questions, help required anywhere? Okay, all right. So we will go back to the model that we worked on yesterday over here. Now, yesterday we were coming into the issue of the room numbers not being properly visible. To move the process forward, what I had asked everyone to do yesterday was to assign numbers to the rooms. But these are just numbers that we have assigned. This is not something that the architect has assigned. All right. So this is something that will happen when you work on a Revit project regularly, that the architect keeps on updating their model. And we need to make sure that we are using the latest architectural model. Okay. So for doing that, there is a system in the links. All the links that we have brought into our project, we can reload those links. Okay. So for that reason, what we are going to do is we are going to go to the insert ribbon. Can you please click on the insert ribbon? Click on the insert ribbon. Insert ribbon, please follow up. Insert ribbon. Is everyone with me right now? Okay. So in the insert ribbon, you have the manage links over here. That manage links will open up this window for you, the manage links window for you. All right. Let me minimize this. All right. Now this is that same model that we were talking about yesterday, that we had linked, right? We had linked the architectural model. This is the same model. What we need to do is we need to update the model now. Okay, why we need to update the model? Because we have gotten the updated model, let's say in this case from the architect's team, that will show the numbers so that we can tag our rooms efficiently. All right, is the objective clear over here? Okay, so with the manage links window open, single click over here, and in the bottom, right click on it and reload from. Right click on that link and then reload from. Right click and reload from. Once you click on it, it will ask you from where do we need to reload this model. Okay, so wherever you have the updated model that you got this morning downloaded on your local drive, navigate to that location, single click on it and open it. Do you want me to show you the steps again? Any questions? Any questions? Please, I need a feedback. If you guys are stuck somewhere, please raise your hand, please call me to your desk, but let's get this resolved. I want you guys to learn from this as much as possible. Okay, so make sure if you've gotten a zip folder, you unzip it before trying to link it. All right, make sure that the folder is unzipped before you link it.
So, professor.
One is from yesterday. Yeah, so there you go. So go to the manage links, right click, reload from, and then navigate to the folder that you have saved the architectural model in. Everyone with me till now? Yes? Okay. Can we move forward? Yes? All right, perfect. Now, we'll come back over here. We'll close this window because we are done with this. Now we'll try to go ahead and annotate the room. Yesterday, what was happening was when we went to the annotate ribbon and we were trying to click on the room tag, since the rooms were not specified by the architect, these room tags that I have on my tooltip over here were not showing up at our end as well. Okay. So again, now we need to tag the room so that we have proper documentation of which room is which room and what is the room number assigned to it. Make sense? Annotate ribbon, room tags. Annotate ribbon, room tags. Click on it. You will see these cross like these. These are basically the limits of that particular room. Making sense? Yes? All right. So we'll go one by one. You will hover over it, click. Hover over it, click. Hover over it, click. So that way you have your room tags being assigned now. Yes. Now you can hover over the room, click on it. Hover over it, click.
So, which
You have uploaded the model.
on the good.
Sorry.
Oh, okay. That's okay.
System already
Let's get you on.
same time and before. No, your model is not. click on the room tag again. If your model is not then go ahead and show me that the latest updated model is in your local drive. Show me so go to view details. One is from the go to the zip code and extract the zip code. Now browse to the location that so you have seen it. Wait a minute. Is it on OneDrive? No, don't use one. As I said, local drive zone. Or just extract here. Download this one.
What is this?
Now on insert, manage links, right click.
Now on the room, so move right on
Assign it on yeah, you have the all right. Okay, so everyone with me till now, the rooms. Any more time needed over there? All good? Okay. So what we'll do is we'll go ahead and tag all the rooms on the first floor. Okay. Let's go ahead and tag all the rooms on the first floor. Simply go to annotate ribbon, room tag. If you already have a room tag in the room, don't tag it again. Just tag it one time. So hover over it, click. That will give you your room tag. Hover over it, click. Hover over it, click. Hover and click. Same thing. Okay, hover, click. So let's get all the room tags assigned to all of the rooms on the level 1. Online, if you have any questions, please go ahead and drop them in the chat box. We'll take those as soon as possible. Alright, so once you're done with tagging, your floor plan will look something like this, where you have the patient room and in the rectangle you will have the room number for the patient room. Online, if anyone has any questions, please drop them in the chat box. This would be required to make sure we answer Tony's questions as well. Any help needed for anyone? How about you guys? All good? Okay. For back over there, everyone has room tags now? Okay, good. So in this row, everyone has the room tag assigned, right? You're having issues? Okay, all right. How about back over there? You guys have room tags? Room tags? Good. All right. How about you folks? Room tags? Good. All first floor?
No, this one is yes. First of all, let's make sure that we have the okay, everyone go to the room chat? Yes. All right, online, just give me a confirmation when you have all of the rooms in the floor plan, first floor properly tagged. All right, good. Lawrence. Okay, good. All good with tagging? Can we move further? All good? Guys, all good over here with the tagging? Yes. How about you guys? All good? How about over here? Everyone done with the tagging? I know, sir, you are copying the model, but rest of everyone done with the tagging? Yes? All right. So let's move ahead with the next step. That is making sure that now we are using this data that we have gotten from the architectural model to do our heat load calculations over here. Okay. So
Let's answer Lawrence's question. The Lawrence's question was these blue cells over here that are needed to be entered with information. He wants to understand that how we have come up with this. Okay. So first of all, we will go one by one. We will talk about the glass section over here. The glass is basically any window or door that opens to the outdoors. Okay. If you have the doors, windows that have glass that open to outdoor, the heat transfer from outdoor to indoor would be much larger as compared to what you have indoors, right? So in that case, what we are doing is we are trying to identify first of all, we'll go room by room. Over here, this will be the north wall. Okay, we'll need to understand the difference between the true north and the project north. Okay, so in this case, what we are going to assume is that this is the true north of the project. And this, if you are standing over here, you are looking at the north elevation of the project. So this is the north wall we have taken. This is the west wall we have taken. In the west wall, you have a glass over it, right? So that is this west glass area that we are entering over here. All right. Now, next point is regarding the delta T over here. Okay. For checking what the delta T is, we have to go and check for what is the ambient outside conditions. For checking what is the outside condition, the ambient outside condition, we will go to this website called as ASHRAE MEP. All right, if you Google over here, we will have ASHRAE MEP. And this option, ashray.meteo.info, will take you to the ASHRAE MEP website. Over here, what we are trying to do is we are trying to find the closest possible weather station to our project. We have assumed that our project is in the city of Kigali. So we will click on search icon over here and try to find the city of Kigali over here. Right? So over here you have Kigali city, Rwanda. We will click on it. Now this website will give us the location of different weather stations that are in Kigali or nearby Kigali. In this case, we do have a weather station that is in Kigali, which is at the Kigali International Airport. If you click on that A over here, that basically means that the pin over there is for the Kigali International Airport. And since our project will very often come across the same conditions what we have at the international airport here at Kigali, we will click on it and we'll try to check what the cooling dry bulb and the mean coincidental wet bulb is over here. All right. Now, as I mentioned yesterday, this data is a historical data. Okay, it's just not like a year, 2 year. It has been over here from 30, 40 years. Whenever the international airport was over here, whenever the weather station was installed over here, the data has been tracked from that time, right? Now over here, what it means is we are trying to check this table of annual cooling, dehumidification, and enthalpy design conditions. The reason being, we are trying to make sure that proper cool conditioned air is given to our indoor I dropped off. Do you remember where I dropped off? Where I dropped off, do you remember?
No, it is.
Okay. Okay. So let me rewind a bit. The internet connection got dropped off. The point I was mentioning was there is two distinct tables over here. There are two distinct tables. One is for annual heating, humidification, and ventilation design conditions. The other one is for annual cooling, dehumidification, and enthalpy design conditions. In places of the earth where it tends to be that you need heating for most time of the year, you would need these numbers for calculating how much heating is required. Okay, let's say your project was somewhere in Siberia or one of the Scandinavian countries. This is what will be dominant because it snows over there. It is cold for most part of the year. Now, since our project is focused in the city of Kigali, cooling is more dominant over here than heating. All right, heating might be required, but very small part of the year. Okay, just because of that, we are not going to invest in the heating infrastructure altogether. Okay, for that reason, we are looking at the annual cooling, dehumidification, and enthalpy design condition table over here. All right. Now over here, as we saw yesterday, from what the historical data shows, the 8th month of the year is the hottest in Kigali. That is August. All right. This is, I know there might be certain conditions that you might come across that the peak seasons of temperature have changed. But historically, if we draw a graph, it's the 8th month of the year, that is August, which is supposed to be the hottest in the city of Kigali. Of the earth, it might be something else over here. Okay, like in the southern hemisphere, it's the opposite seasons, right? When it is December and cold on the northern hemisphere, it will be hot in the southern hemisphere, right? Now, talking about these values over here, there are three distinct values. This means that for 0.4% of the year, okay, these particular numbers will be applicable. For 1% of the year, we are talking about time, right? 1% of the year, these numbers will be applicable. Okay, and for 2% of the year, the time, these numbers will be applicable. As I indicate, okay, in case there are special conditions that a senior engineer is asking you to use, the reason being, as you see, these numbers drop down when you take a bigger chunk out of the year. The reason being your average is coming down. Okay, over here, this is the worst case scenario that we are working with. Okay, if we have our ACs designed to this temperature, basically this 2 degrees Fahrenheit lower as compared to what we have for 0.4% over here. All right, so basically we are trying to go with the worst case scenario. How much hottest it can get for a small period. We'll design our HVAC systems for this number, 86.3 degrees Fahrenheit, and the mean coincidental wet bulb temperature will be 65.5 degree Fahrenheit. All right, these two numbers is what we are going to plug in over here, 86.3 and 65.5. Is everyone clear till now? Yes. So you have 365 days in a year, right? 1%, or you can take it into hours, you can take it into seconds. 1% of all of those days, this temperature will be dominant as per the historical data. Right? Now, if you take that same 365 days, 1% of that 365 days, whatever it is, 3.3 something, this particular number will be applicable. All right. So very short period of the year, this will be applicable over here. But to make sure we are designing our HVAC systems for the worst case scenario, we are using the worst case scenario over here, which is 86.3. Yeah. Make sense? The E20 spreadsheet. We have any issue? Any issue? Okay. Okay. And this number, this is coming from the extensive exercise that we did for the ASHRAE 170 guidelines. Right? We went into ASHRAE 170, and let me open up that presentation again. Okay, over here the other day we were talking about some problem solving where we understood that the patient rooms, right now what we are looking at is a patient room for the hospital, correct? So this is the patient room that we are talking about. As per the standard 170 of ASHRAE, what we are trying to degree centigrade or 24 degrees centigrade, right? That is the range. That is the recommended range by ASHRAE based on the empirical data that they have collected from various locations of hospitals. All right. Okay. So with that, we come to the indoor. The indoor temperature, what we are trying to maintain, something was around like 23 degree for a patient room, because we have gotten a range of 21 to 24. So we are planning to set our set point at 23 degrees centigrade, which roughly translates to 73.4 degree Fahrenheit. All right. Now, the difference of outside and inside temperature is giving us the delta T. In this case, it is 12.9 degrees Fahrenheit. That is the same 12.9 degree Fahrenheit that we have entered over here. Make sense till now? I'll repeat it again. Okay, all right. So going back over here, did you understand this one? How we got the data from the ASHRAE Meteo website? Right? That concept clear? Okay. Second concept regarding the indoor temperature that we are trying to maintain. Is that concept clear? Okay. Now, outdoor temperature minus the indoor temperature. There is a difference, right? T2 minus T1. T2 minus T1 equals to 12.9 degree Fahrenheit. Is that making sense? All right. So that same 12.9, we are getting it over here. We are typing it over here. Make sense? All right. Now, talking about the U value. We are talking about this equation to begin with over here. It is the equation, basically we can call it the holy grail of HVAC industry. QA delta T. Q equals to UA delta T, right? And the U over here is the thermal resistivity that you will come across between your facade element and the indoors, right? The facade element, in this case, it is the glass that we are talking about. The glass that is facing the west direction specifically. All right. Now, how did we get that number? We used another energy efficiency standard of ASHRAE, which is 90.1. Okay. So if you're with me till now, so that I have your doubts cleared. Okay, down over here, again, this is the same ASHRAE website where we got ASHRAE 170 standard for. You use this to calculate the minimum outdoor air changes per hour, the pressure as compared to the adjacent space, right? Now we are talking about the ASHRAE 90.1 standard over. right? Let's go ahead and open it. Bear with me till it gets loaded, but till that time what we can do is we will hold on to this U value for now, but we'll talk about the walls now. Okay, just like we had the window that was facing outdoors, now we have a wall. We have two walls that are facing outdoors. This is that one wall, this is the another wall. All right, vertical walls facing outdoors, correct? The wall over here is north facing wall, north facade wall, right? That is why we are using wall dash N over here. Next, what we are trying to measure over here is the length and height product. Length into height, we are getting it as the area. Basically, that area is exposed to the outside condition. Heat transfer can happen through the entire face of that area to the indoors. Yes. It doesn't have. It is a. Sorry. So let's say it. Okay. So you're saying that it is tilted.
It has no external.
Yeah. Then you will not have anything over here. Right. Basically, if it is an interior room that is not facing any facade, there will be no exterior wall because there is no solar transmission or heat gain happening from the wall, right? And that is technically called a partition. There is a buffer zone between the exterior wall and the partition, and that's why we don't include it over here. Make sense?
So, you just not that before, or you?
No, if you don't have any walls, roof, floor that is facing the exterior condition, you need to only consider the internal load. There will be no external load acting on your room, right? Does that make sense? Okay. All right. So next, regarding the 9, you'll see everywhere 12.9. Okay. Excuse me. This north wall, we measured it at 129 square foot. How we did it? We created the sections. Right click, go to view, and we simply measured the length over here and the height over here. That product of the length and the height gave us the 129 square foot that we are talking over. Similarly, just like we have a north wall, we have a west wall, right? Now the west wall also has a window, correct? So this was the window that we were talking about yesterday. This is the west wall. What we did was we measured the area of this west wall and then subtracted the area of the window, right? The area of the window is 21 square foot. We subtracted 21 square foot from whatever the area of that entire wall was, and that effectively gave us the area of that wall, which is basically an opaque wall, all right, which was 88 square foot. Make sense till now? Oh. Now, next one, hopefully Ashray website has opened. Oops. Okay, till this page opens, let's discuss. We'll keep the U values finding on hold for two minutes for now. Next, we are talking about the floors. Now, if you have the room whose floors are basically touching the ground, earth, right? You have possibility of heat transfer happening through the earth as well, right? At the end of the day, it is unconditioned conditions outside, and there is chance for heat transfer to happen from the floor as well, right? For that reason, if you have your room on the ground floor, where that room is directly, the floor of the room is directly in touch with the earth surface down there, you will need to enter the floor over here. If this room was on the second floor, it is not directly above the earth, then you will not need to enter the floor area over here. And how did we measure the floor area? We simply measured what this length times width is of that roof. So whatever 12 foot by 10 feet 6 inches was what we used for the area of the room, basically the area of the floor that we are talking. Okay, going back over here, next, let's see if Ashley has opened. Okay, so now let's go back to the U value finding. Okay, now the U values are something that we have been taught in our school again and again, the thermal resistivity, right? If you have, let's say for very easy example, we have insulation on a duct, right? Or insulation on a chilled water pipe, or even insulation on refrigerant piping. That is meant that the cold fluid that is passing through the pipe, or the cold fluid that is basically the air passing through a duct, does not give coldness to the exterior surfaces. That's why we have the insulation on top of it, right? So consider your walls as the same thing. If you're trying to cool the surface indoor with your AC and you don't have proper insulation to your wall, that heat is going to basically come in as much as possible and add to the temperature. So the 23 degrees centigrade that we were trying to maintain is not being able to properly maintain because the temperatures are coming indoors as much as possible. Is that concept clear till now? Now, going to the ASHRAE 90.1 standard over here. Okay. Now, this is a standard that we usually, as MEP consultants, usually use in tandem with the architectural team as well. Because the walls, the windows, the facade, that is the scope of an architect. It is not the scope of MEP consultant. But as responsible consultants, we need to nudge the architects in the right direction. That this would be the most energy efficient way of using the particular facade or the wall or windows or window panes. So yesterday we had a good discussion regarding a single pane and a double pane window, right? Single pane window will always have low thermal resistivity as compared to double pane window. So we as engineers, we need to push the architects, owners to make sure that they understand putting in two pane window, maybe with air in between the two panes or argon gas in between the two panes or any other inert gas in between the two panes will increase the thermal resistivity of your facade so that you don't have to run the AC switch. Does that make sense? Okay. Now, going back to the ASHRAE 90.1 standards, similar interface where you have bookmarks on the left, you put the plus sign over here and you basically come down over here, and over here you will see the normative appendix A rated R value of insulation. Along with that, there will be annexure 1 reference standard for reproduction. So once you click on this annexure A, first of all, it will give you the details regarding different geographies. Okay. The resistivity values that are allowed as per ASHRAE standards also depend on these particular values for the zones that we are looking at. So let's say if the project was somewhere in the Proverbs county of Colorado in the US, 4B conditions, climatic conditions would be applicable. But yesterday we saw we did not find the table for Rwanda over here. We did not find a table for Kigali. So what we ended up using is we ended up using a generic R value. Okay. Generic R value are usually better as compared to the tailored R value for the climate zone. Why? Because we are trying to gauge the heat loads for the worst case scenario. All right. But if you do have a project which fits in one of the proper given climate zones over here, I would recommend using that table for that climate zone. Okay. Now, going back to what we were talking about in the session yesterday. Okay. So once you come to this particular normative appendix A, right? Over here, you'll start seeing tables when you go deep into the particular section. Now over here, what first is given to us is the rated USMB for roof with insulation entirely above the deck. Okay, so if you have a roof and you have insulation on top of it, this is the particular table that you'll use. All right. Next, let's go ahead and check for different ones. This is for metal buildings roof, but we are looking for the windows. Okay, so let's check for the windows. Where can we get the information for windows? So this is again roof. Still talking about roofs. We have come to walls. We'll revisit the walls in some time. We will focus on the window panes for right now, since that is the first one in our table. This is for concrete. This is for walls again. Does anyone remember which page was it yesterday that we were looking at? Okay, yeah, this one. So over here, what we have is the R values that are for the visible transmittance of vertical fenestration. Okay, fenestration means what we have over here. The doors over here become the fenestration, and over here we get the information for the view factor. All right. Again, as I mentioned, if you have a clear glass, your thermal resistivity will be lower as compared to what you would have for a tinted glass. All right. So over here, what we are talking about, well, let me take that back. The solar heat gain coefficient. So this coefficient is required when we are doing energy modeling analysis. Basically, how much heat is absorbed by the pane itself and how much is transmitted. That is what will be given. All right. The U value necessarily do not change from the clear to tinted windows. All right. So in this case, what we had used was metal, because we had checked in our model that the windows were made up of aluminum. So over here, we understood that the rectangular mullion over here was made up of aluminum. I selected that mullion, clicked on edit type, and the material came with as aluminum, right? Based on that, I understand that the architect is looking for aluminum window frames, right? Now we go to the metal frame and other types over here, okay? Now we do see that there are only options for double glazing and triple glazing, all right? But the thing is, the architect has not shown any double glazing. It is just a single glazing that they have shown, okay? It is our responsibility again, since I was telling this is kind of a collaborative effort. We need to make them understand that having a double glazing would be better because your AC systems will be running far less as compared to what having a single pane would. All right. So in that case, when we were looking at this number over here, 0.9 was the U value for a double glazed metal frame window. All right. And that basically was what we had entered for this window over here. Did that make sense till now? Everyone following? Yes? All right. Then talking about the walls. We spoke about the walls. Now, there are different types of walls if you see over here. There are above grade walls, there are below grade walls, right? So basically above grade is whatever is above the earth surface, right? If you have a basement, then you will have a below grade wall, right? But in this case, we are looking at a above grade wall. That is why we'll go to the above grade walls section. And over here, in the US, they have the stud system, right? They have their houses, their buildings built from studs, right? They have studs and then they have framing for the studs. They have chipboard or any other RCC membrane on the outside and inside. They fill all of that with insulation, okay? But in countries like our, be it Rwanda, be it India, we'll have mass wall, right? We'll have bricks. We'll either have like masonry bricks or we'll have fly ash bricks, so on and so on. So in that case, it will be the mass wall. Basically, it is a masked wall with some plaster that will be added in the exterior, right? So for that, we are coming to the mass wall over here. And that mass wall will also have a table associated, right? So we are talking about the above grade concrete walls and masonry walls, which is the predominant wall type in our geography over here. Now over here, we did mention that the wall yesterday we checked, how much was it? Something like 8 inches or 9 inches. Yeah, around 9 inches. But we had checked that we are only limited with 8 inch over here, which is fine. The better the thickness of the wall, the better the thermal conductivity, right? So it is always better to have 2 jackets if you are feeling cold than 1 jacket, right? So greater the thickness, better the thermal resistivity. So it is fine if we enter this over here, these values over here for no plaster in the outside. So these are the R values that we are considering over here. So the R value for an 8 inch wall, 8 inch thick wall is R 30.4. Okay. But you might ask me, we were talking about the U value over here. What is this R value? R value is the reciprocal of U value. Okay. So if you take the calculator, do a 1 divided by 30 point, what was it, 8? So that gives us around 0.3. What is it, 30.4 or 30.4? Or did we take something else yesterday? 0.83. Okay, looks like we had taken some plaster outside of the wall. Okay, so if there is no plaster outside of the wall, we'll take it at R equals to 0. Okay, for that plaster that is going outside. But in this case, we were restricting ourselves to a plaster that is around 1/8 inch. The plaster which is around 14 pounds per square cubic feet of the concrete wall in the outside. Okay, that is the reason why we had 0.083. Okay, in case we understand that there is no plaster in the outside, we'll go with the R0 because there is no added insulation to it. Okay, it is just a masonry wall that is facing the outdoors. That is where we were getting the 0.083. So in this case, when we go over here, that is the 0.083 that we had entered for the west wall as well as the north wall. Okay, so far, is it making sense? Or did I lose you somewhere? Making sense? Okay. Sure. Okay. I would recommend that you do a good reading through the ASHRAE 90.1 standard. It is a standard that has been used very rigorously all throughout the world. So it will not just be in Kigali, it is also used in Middle East, it is also used in India, it is also used in Australia, because this is kind of like the baseline that they are calling. If you are working on a LEED certified building, this will be your baseline that you will be designing all of your systems with. So your systems need to be better as compared to what ASHRAE 90.1 has described. Right? Okay, so going back to the spreadsheet, we are done with this information over here for the up till the floor, right? Now we are talking about the outside air. Now outside air comes into picture when we were talking about the minimum outdoor air changes per hour over here, right? The patient rooms had the minimum outdoor air changes per hour was 2, all right? Based on that, what we have done is we have calculated the CFM that is required as per the air changes per hour. But if we enter the air changes per hour, that will also give us the CFM that comes over here. Okay. So basically, this is the outdoor air changes per hour that is required to be 2 minimum. That is calculated for the CFM value. How did we calculate? Again, we took the volume of the room, right? Volume of the ACH is the CFM into 60 divided by the volume of the room. Area times the height. Does that make sense? Sure. Do you want me to show the calculation again? Let me check. I'll show the calculation. Today hopefully it will open us now. Okay. So over here, this is just a calculator that I've gotten online. The ACH is CFM into 60 divided by the area into the height of the room. Right? So now yesterday, how we got this, we had the area that was 129, correct? 126. So basically the floor area is what we will take for the room. The height was somewhere around like 9 feet 10 inches. Now the airflow is what we need in cubic feet per minute, but the air changes per hour was 2. So based on that, we had around like 41 CFM that we were talking about. And over here, let's take a look over here. The 41.29 is considered over here. Okay. And this 17.56 is based on 62.1 standard. We'll talk about that in a minute. So 62.1 standard is another standard given by ASHRAE for calculating the outdoor air. Okay. So now that is specifically focused towards the towards occupancies except the hospitals. Okay. So in here you will get information. I'll open that in a minute. But this 17.6 that we are getting is from that point. Okay. So this 17.6 in addition to the 41.29 CFM that we got from ASHRAE 170 is what we will be using to calculate our total outside air load. Is that making sense till now? I'll show the 62.1 as well in a minute. I see a bit of blank faces. I see a bit of blank faces. Okay. Give me 2 minutes. Let me finish this one.
We will go for coffee break at 6 p.m.
6 p.m. Right? Okay, that's fine. So over here, this is the ASHRAE 62.1 standard, which is required for occupancies except the hospitals that we are working with. And over here as well, we will have the table. This is, again, I don't want to confuse you too much. This is a table that is required for providing outdoor air for occupancies except the hospitals. So over here, that information that we are getting in the E20 spreadsheet over here, first is the CFM per person is 5. So here you have the CFM per person. So in this case, let's take a look if we do find some kind of something closer to a hospital space, but not exactly. We have a reception public. Okay, looks like we don't have anything closer to a patient room. So what we will do is we'll keep it to the minimum, the 5 CFM per person and 0.06 CFM per square foot. So basically based on that, you'll have 2 people in the given room, the patient and their guest. So both of them would require 17.56 CFM of outside air, in addition to the 41.29 CFM that we are getting from the 170 standard. All right. So the total CFM that we are supposed to bring from outside is 17.56 plus 41.29. Okay. That is of course good because we are looking at the minimum air changes per hour, right? So if we have more CFM, the ACH will also improve. Does that make sense? Or did I lose you?
Yeah.
Making sense? Or no? There are some blank faces. Sorry. Okay. But is that making sense? Basically, we are trying to bring the outdoor air indoors to make sure there is CO2 buildup does not go to high levels and we have proper circulation of the air going on. Is that making sense? Yes? No? Okay. So we'll take a quick 5 minutes break, a bio break. If you want to use the restroom, please use the restroom. I know again, we are going through the same topics that we have discussed yesterday. But again, yesterday we were close to getting done and then we had concluded the meeting. So 5 minutes break.
2 minutes.
2 minutes.
Siko gahunda zimeze abantu bambaye imyenda y'icyatsi kibisi bose bananiwe. So tusohoka hanze mugende muzenguruka hano muze mugaruke twaje nta kusiga.
For the folks online, we are taking 2 minutes break. So if you can please hold on. And okay. All right. So getting back on track, we spoke about the air changes per hour. We good? We good, Emmanuel? Yes. All right. We spoke about how to calculate the areas, how to find the temperature difference, how to find the U values. This we got it from the area, we got it from our floor plans, from sections in Revit. Over here, we got this value in 2 parts. First is the ASHRAE Meteo, second is the ASHRAE standard 170. This we got it from ASHRAE 90.1. Make sense? Over here, this CFM, we are pulling it from ASHRAE 62.1 standard. This is the outdoor air that is required from 62.1 standard. But we are going to increase the CFM because we need to make sure that the minimum air changes per hour of 2 are maintained. All right. Next, we are talking about the number of people. As we mentioned yesterday, yes. What about infiltration? We are coming on the next tab over here. So we are talking about CFM infiltration over here. So we'll talk about that in a minute. All right. Okay. So let's talk about the people over here. We had two people, patient and their guest. Okay. Most of the time, you can also consider patient because guest is intermediately over there. As we can remember from the first day, we had patient rooms, and they are the ones that are exposed to the climatic conditions, indoor climatic conditions again and again, right? So that's why, but making sure we have our equipment adequately sized will take two people. And this is the BTU per people. Again, as humans, when we do any type of activity, even sitting, we have different metabolism rate as compared to, let's say, we are jogging, right? So as we start doing that, you will have your metabolism increase, and that basically is increasing the BTU per hour per person. Okay. So in this case, the BTU per hour per person is 230 for two people, 230 for one person. That multiplied by 2 will give us the BTU per hour that is given by the two people. ASHRAE, but this is from the ASHRAE Fundamentals book. I'll take a snippet over the break because ASHRAE Fundamentals are not read-only available. They are the ASHRAE handbook. So give me some time over the break. I will share a snippet with you guys, since it is a proprietary material and ASHRAE does not allow to share it as a big portion. Next, regarding the lighting. As we mentioned, we are taking the lighting as a metric of the square footage, right? So it will be 1.25 watt per square foot. So the total area of the room is 126 square foot. That into 1.25 will give us the heating that will be emitted by the lights. Okay. As I mentioned again, yesterday I mentioned that the lighting technology is increasing, it's becoming efficient rapidly. Okay. It has become LED now, which is close to around like 99.5% sometimes. It's very efficient. How much energy you put into it, how much power you put into it, that many lumen levels also you can get out of it. But this was not the case when it was like fluorescent lamp or incandescent lamp. They used to emit a lot of heat. Okay. In the yesteryears, we had to take that heat also into account to make sure our ACs can handle that heat. Okay. In that case, this watts per square foot was much higher, but now it has gotten lower. So in some cases, you will even find 0.5 watts per square foot. That is allowed. All right. Maybe for a small storage area, you don't get a lot of allowances over here. Okay. And this also you can get it from the ASHRAE 90.1 standard. Okay. So again, I'll not jump deeply into it. I have shown it yesterday. The video is available, but that is where the wattage per square foot concept we are coming from. All right. Next, talking about the equipment. Now in a patient room, in a typical patient room, of course, there will not be heavy equipment, but there might be chances that there might be heart rate monitoring stations, any other stations that might be required for particular illness. For that, we need to make sure that this number comes in from the vendor that is supplying that equipment. Okay. Even the doctors can give that information, but usually it is the specialty consultant that we are talking about the other day, right? There will be a hospital specialty consultant who knows, who works with the doctors, who works with the owners to specify these products. Make sense? So right now, this is an assumption. The 1 kW that we have put over here, 1000 watts that we have put over here is an assumption that that equipment that we are specifying over here, it will emit about 1000 watts of heat. With me till now? Yes, question?
So actually when you check the equipment, you see the wattage.
Correct.
Which is our unit.
Correct.
Then you see the emittance power.
Exactly. Right. So yes, So the question over here was, if we check an equipment, there is a wattage that is given on the equipment, right? If you check properly, that wattage is the product of the voltage times the amperes times the power factor. That gives us the wattage, correct? Straight and simple formula, right? If we take that number, that will be the higher number as compared to what the heat is being dissipated. Okay, we'll take an example of this projector over here. Okay, so the energy that is being input into the projector, I think so it's somewhere around like 5 ampere plug over here. The voltage in Rwanda is 220 volt, correct? 220 volt, right? So 5 into 220 into, let's say, 0.8 power factor, right? That will be the energy that is being consumed by this particular projector, right? Now that power is being used to emit the light over here, which is through the bulb that is in there, the lamp that is in there, right? There is another component which is emitting heat as well through that light over there, that lamp over there. Technically, we are supposed to use that one. Okay. To cool the transformer. Making sense? For that reason, we can directly use the wattage value that is being given over here. This also gets applicable to data centers. I think so. You were the one who mentioned data centers yesterday, right?
Yes.
Data centers.
Which one is it?
The one which you get through the plug, that is the higher, right? So that higher gets divided into this function of the lamp as well as the heat. So it is better to have our equipment model for the higher one if you don't have explicitly the heat dissipation values from the vendor. Okay. In my career of close to 1.5 decades, I've hardly seen, maybe on one project in one equipment, I've gotten that heat dissipation value. That was because it was a plotter. Plotter for plotting big sheets. We have big sheets for our construction purposes, right? So in that case, I had gotten the heat dissipation value. But if you're not getting the heat dissipation value, please make sure you're using the worst case scenario. Make sense? Okay, so in this case, we have the wattage for the equipment considered as 1000 watt or 1 kilowatt. Next, we are talking about the infiltration. Okay, this is the infiltration that we are talking about, right? Sir, infiltration we were talking about, right? Now over here it is 0, but we'll make sure that the infiltration is accounted on this part over here. So the CFM infiltration we are looking at is from 2-3 different types. Okay, the first one is the swinging. If you have swinging doors that open to the outdoors, right, that will be entered over here. This will be the square footage value over here, foot value, right? And then this will be the CFM per door, or let me reverse that back. If this is a CFM per door, so you'll need to enter the number of doors over here. In case you don't have the number of doors, you have the length of the perimeter of that door, you can take that and multiply that with 1 CFM per linear foot. That will be the air that can be infiltrated into our zones. Make sense? Yes. All right. Now, next thing is regarding revolving doors for people. You do have in big lobbies, nowadays it has become less, but you do have revolving doors, right? In that case, you just need to multiply how many number of doors into the CFM per door. The open doors, if you don't have, what do you say, what? The sliding doors. Sliding doors will come under this one. Okay. Now we are looking at cracks. Okay. The cracks is basically the cracks that will be happening at the point where the floor and the wall meet each other. Right. To the outdoors. Again, we are talking about outdoors. The air from outdoor is coming indoor. It's trying to get indoor. That is called the infiltration. All right. So over here, it is not the area that we are looking at. We are looking at the lineal foot or lineal meter, whatever it might be. Okay. We are looking at length, not the area this time. Okay. So over here, the length we will check from here to here. It was around 12 foot, right? And then from here, around 10 foot 6 inches. So 12 foot plus 10.5. 22.5, correct? 22.5 foot is what our crack will be for that particular wall. So you will post. Sure, yeah. Slab also we can consider, yes.
I mean, like crack. Where the wall meets the
Upper floor, yes, we can consider that as well. There is the seal. Of course, in ideal world, when the building gets built, the contractor, of course, will take warranty for 1 year, as I was saying. For 1 year, it will be fine. But as the building ages, the loads start getting settled on it. There will be minute cracks that will be coming into your building. Okay, that will arise the problem of infiltration. Okay, what happened? All good. Okay, so now going back to our sheet over here, 22.5, and we are taking it as industry standard 1 CFM per square foot, which we are getting as 22.5 CFM of infiltration load. All right. So now taking a look over here. So these numbers that I was mentioning yesterday, right? So this is basically based on this formula over here. Okay. So over here, if you see U area into the delta T will give us this number, which is BTU per hour. Basically, indirectly, we are getting the tonnage or kilowatt, whatever we call it, for the HVAC load. Same thing happening over here. Same thing happening over here. The fundamental formula stays the same. Next, over here, for the floor, again, the same thing is happening. We are getting this value over here based on the same formula. Next, talking about the internal loads, right? This is a simple multiplication, 2 into 230 BTU per hour per person by the equipment, all right? This is 1000 into 3.41, because if you convert wattage into BTU per hour, that is the conversion ratio. And basically what we are getting over here is the addition of this column, which is giving us the information for that. The comment in house for the folks that are online. I got a suggestion that I got a suggestion from one of the in-house participants that we get to know where this information is from. So what I'm going to do is I'm going to save this spreadsheet and I'm going to right click on it and add note. And over here I will add from Revit, right? Over here I will add from difference between ASHRAE Meteo and ASHRAE standard 170. All right. So this way I will make sure that I enter this information. So whenever you are on the spreadsheet, you will get an idea. So I'll do an applicable over here, so on and so forth. Make sense? All right, perfect. Okay. So now, is it clear? Unit or 1.9 for this particular patient room. So the equipment that now you're ordering from the vendor, be it Daikin, Mitsubishi, Carrier, whoever it is, it needs to be rated for minimum 1.94 kilowatt. Minimum. You can go above it, that is fine, because not every manufacturer will have 1.94. They might have 2 kilowatt, 2.5 kilowatt, whatever it might, right? Similarly, it is 1 ton, 1.5 ton, 2 ton, 3 ton, 4 ton, 5 ton, right? It is good to go above. Do not go below that range. If you go below that range, you're not meeting the heat loads. Basically, that AC will run full time and still not be able to meet the space condition of 23 degree that we are trying to maintain.
Specifically for that room, not for every room.
Not for every room. That's, yes, just for that room, it's 6.69 MBH or 1.94 kilowatt. Okay. Now, if I was doing this project, I will go one by one and do everything. Okay. I know that is a lot right now. Okay. I do understand we are running against the time. But the thing is, I want you to try this out. This was just a trial. Okay. You now understand where, the biggest thing is you now understand where to find the minimum outdoor air changes per hour, where to enter it in that spreadsheet, how to find the area of the walls, windows, how to find the U value, how to find the outdoor air conditions, the ASHRAE meteor, how to find the set point, indoor air conditions, ASHRAE 170. One by one, you will take each of the load of each room, because what we have load for this room will be different as compared to what we have for dispensary. Can anyone give me the reason why it might be different for room number 1 and room number 2? Just spitballing ideas over here. Why might be patient room 1 and then number 2 dispensary room heat load different? Bigger. Correct. Different sizes. What else do you think? No windows, right? More windows. Sorry, yes, there are 3 windows, right? So the solar, the solar transmission will be more as compared to what we have in a patient room, right? What else? Any other points? More number of people. So we got one from folks online. More number of people, right? In dispensary, there might be 2-3 people more for facilitating whatever the medicines, whatever is going out, right? More or even less number of people, whatever be the case, right? Sorry? Equipment might be more, right? Sorry, I didn't. The lighting, yes, lighting might also be more, right? Because it is a bigger room, the lighting requirements might be different, right? So every room will be different. Okay. Again, as I mentioned, I will give you the important things that you need to consider. First of all, the minimum air changes per hour for outdoor. Very important that we take that into consideration. Indoor environment temperature that we are talking about. Very important that we take that into consideration. All right. The equipment. When let's say you're working on a MRI room, that equipment is huge, right? The CT scan is huge. The amount of heat dissipated from that equipment might be even more in the tunes of 30 to 40 kilowatt. Okay. I've seen those equipment going 30 to 40 kilowatt. So that is a big room, big AC unit that might be required. Of course, that AC might not run full time. The MRI is not always occupied. It will be maybe occupied 1 hour, 2 hour. So you can maybe take some kind of diversity. We'll talk about diversity when we are talking about electrical engineering in some time. Okay? Does that make sense to you? Yes? So now I want to make sure that you guys understand how we will begin in Revit, because that is our fundamental goal over. Okay? Now that we have understood that patient room requires a cooling load of 1.95 or 94 TR, what we will do is we'll start doing work in Revit. We'll start showing equipment in Revit. Okay? So let's get started. Yes.
Just have another question.
Sure.
From there, we consider the area.
Right.
But the buildings might have different heights.
Correct.
Can it affect the calculation?
Yes, it will. It will, because over here we are taking the height of the room for calculating the volume, right? The height of the room over here. So in this case, it was 9 feet 10 inches, but the heights might be different of the room. So if that is different, your area of the walls will be different. For calculating CFM will also be different, because you are talking about the air changes per hour, right? In the air changes per hour, if you check, we have the area and then we have the height of the room, right? So since the volume will increase, the CFM will also increase. Make sense? Okay, all right. Let's now get into Revit and start the modeling. But before I go into this, I would thoroughly request all of you to go at least to 4-5 rooms and do the heat load calculations. Okay, we do have tomorrow as well, right? There is some session tomorrow morning.
Yes.
In tomorrow morning, it will be more focused towards the Revit work. But for getting you started on the rooms, typical rooms, we will get started on Revit. In detail, it will be tomorrow morning that the team will be going through. All right. Okay, let's get into Revit now and start modeling it. So now we have the floor plan set up for Revit. Right, over here we have the floor plan setup. As I mentioned yesterday, properties and project browsers. Please make sure this user interface is always on your screen, so that you can understand which part that we are looking at. Okay, so now what I want you to do is we will talk about the diffusers. We have grills, registers, diffusers, right, in HVAC, correct? So first we will place the grills or diffusers in that patient room. So for that, what I want you to do is go into this systems ribbon. Click on the systems ribbon. Just let's click on the insert ribbon, not the system ribbon, the insert ribbon. And in there, you will have the load Autodesk family option over here. Yes, click on it, please. You will see something of this window showing up. Just insert ribbon. Okay, after that you will have the load Autodesk family option on the load from library on the right hand side. Not showing up. You got it? So click on that. It will open up this window for. Got it, everyone? Okay. Okay, there was one question from Lawrence. It is something similar to what we had discussed some time ago. The question goes, how do you apply this E20 spreadsheet for spaces that don't have any walls to the outside weather? Example, room number 9, admin area in our practice drawings. Okay, so let's take a look into that before we move forward. So, okay, he's talking about this area. Okay. Now this area does not have any walls, does not have any windows that are focusing outside, right? So that makes these walls as partitions. Okay. We will not take them into consideration because we do have buffer areas like this admin area, the arch area, the mail ward area as a buffer to that room from the outside conditions. Okay. But we need to make sure we understand the heat load caused due to the people as well as the equipment as well as the lighting in that room. Okay, so Lawrence, to answer your question, there will be no wall or window assigned in this area. It will be only the internal loads, people load, lighting load, equipment load that we will consider for this area, and based on that we will have our HVAC system sized. All right, so going back, load Autodesk family, just keep me posted if they ask the questions. He had asked a question, just keep me posted. Okay, so this is the window that we have. Everyone on this window with me? Yes? All. So basically what happens is there are three types of extension when it comes to Revit. So over here, if you see, this is the project.rvt. Okay, just like for images, we have JPEG, PNG, right? Those kind of extensions. Just like that for Revit, there are different types of files. We have different types of Revit extensions. When it is a project that we are working in. That is a .rvt file. Okay. If it was a template, yesterday we began this project with a template, right? That will be a RTE. Okay. If it is a family, we'll speak about what a family means in Revit. That has an extension .rfa file. .rfa. Okay. So sometimes people even call it RFA files. Send me the RFA files. Don't confuse that with the RFI files because that has happened in my office quite a lot. Okay. The same thing means Revit families. Okay. What are families? Basically, we are now working in a project, right? We are working in a project. We require the equipment to show up. Right? That equipment will have a family of itself. All right. Basically, it will be a block, a data rich block that will be used to show the equipment on the floor plan. Making sense? All right. So for that, we are trying to load the Autodesk family over here. Once you click that, you will be directed to this window. Please note, in versions Revit 2022 and before, this was installed already on your local drive. After Revit 23 and later on, this option is available over here. This is basically connecting you to the online cloud where Revit Autodesk takes care of maintaining these families over here. Okay. So when you have a club of different types of family, it is called a library. Just like in a library, you have different books, right? Just like that, you have a library, let's say, of conduits. Then you have a library of mechanical equipment, so on and so forth. Okay. When you're working on a project and you want to download a family from here, always make sure that your region is set correctly and your language is set correctly. Just like the template that we were using yesterday, it had Chinese, it had French, it had Portuguese, all of these languages. Make sure you are working with the correct language. In this case, we are taking the United States Imperial because that is what our file was with. But you can even take metric, English metric, whatever it might be. All right. Now, this is on the left hand side, you will have the options for the family libraries. Yeah. What we need to do is check for the mechanical libraries. Once you single click on it, it will the tree will open for all of the equipment all of the families that are available for mechanical systems. Okay, with me everyone? Okay, there is a point online. It says I am unable to load. It says I should install the content locally. Okay, all right. So looks like you have installed the Revit package without the families. So if you do have access to someone else, Tabakalt, if I'm sorry if I'm butchering your name, if you do have access to someone of your colleague, please take that family in a pen drive from them so that you can use it for the period right now. Okay. Okay, going back to the mechanical side, we are trying to find the grills, registers, diffusers. If you scroll down over here, they are called as something called as the air terminal. Okay, it is at the very end of the duct size, so it is called the air terminal. Now there are different types of air terminal. There is an exhaust grill, exhaust diffuser, supply diffuser, which is rectangular, right? Supply diffuser, that is sidewall, supply grill, which is perforated with rectangular neck, right? So different types of grills that will be used. Okay. In this project, usually there will be, in a patient room, there will be a false ceiling. A false ceiling might be a grid ceiling, 2x2 grid, or it might be chipboard ceiling like this ceiling that we have over here. Okay. In this particular project, we'll talk about how do we tackle that point. But for this particular patient room, what we will use is a linear slot diffuser. So let's try to find a linear slot diffuser if there is. You can even try to search it over here. So yeah, over here you see a linear slot diffuser. Has anyone seen linear slot diffuser in the past? Yes, right? So we will just have a quick view for those of us who have not. So it looks something like this. It's a linear, right? It will have airflow that will be supplied to the bottom through that slot, right? So now we are taking the supply diffuser with plenum, single clicking it and clicking on load. Okay. So that will start downloading the families for us for that particular linear slot diffuser. Okay. Yes. Okay, so this point we'll take and then we will go for a short break of 15 minutes. So over here, this specified type option will pop up if your family has multiple versions of that family. So in this case, there are multiple versions as you see over here. There's a 24 2 to 6 inch inlet, one slot diffuser. Then there is 24 inch by 2 inch width, 24 inch length, 2 inch width. And then the inlet is at 8 inch. That's what we are talking about, right? So in this case, for our purpose, we will keep it reasonable and try to make it a 24 inch by 3/4 of an inch, 6 inch inlet with a 2 slot diffuser. Are you guys with me? Please select that one. Are you guys with me?
Yes, sir.
Yes.
Okay, we are talking about 24 by 3/4 inch, 6-inch inlet, 2 slot. Sorry? 24-inch, 24x 3/4 dash 6-inch 6IN inlet, 2 slot. Is there everyone with me? Need any help? Online folks, please drop your text if you need any help. Oops. Okay. He removed this thing. So, right now, I think so we are cancel over go back to load Autodesk. Go to the globe of Autodesk. Now everyone look up and hit OK. Let's go ahead and click on it and hit OK. Then you have highlighted it, hit OK. That family gets in your model. Everyone hit OK. Yes. Okay, then we'll break for 15 minutes. It is 6 p.m. right now. For the folks online, we will be taking a break of 15 minutes. Please make sure you come back on time. So Tony, when I was talking about the globe, make sure that you have your globe set to US Imperial. Let me share my screen once. Okay, I'm sharing my screen, Tony, for your information. Load Autodesk family over here. You have the local setting over here, the globe over here. Click on it and change it to United States Imperial so that you can see in inches, in feet, and so on and so forth. That will give you the option for inches and not just mm. In case your client is asking for mm, you can use the appropriate settings as per the country. If not, UK for mm, US Imperial for FPS system. I hope that answers the question, Tony. All right, then we will break for 15 minutes. All right. Yes, just yes. All right. So welcome back after the short break that we had. I know we are trying to make the breaks smaller and smaller as possible, but we want to make sure that you get all the information, all the training as much as possible before we get done with the course. During the break, I had an interesting conversation with some of the in-house people. It was regarding Autodesk forum. So some of you had questions like this: what I'm teaching is well and fine, but what happens when I get stuck at a specific doubt, right? What if you're not there at that time, or I'm not able to find a proper solution? So I would strongly recommend exploring the Autodesk forum. Okay. If you simply type in Autodesk forum, this will be the first link that will be showing up.
This is basically a forum that is run by the users of Autodesk products. Okay, there are many Autodesk products. Revit is one of the tools that is developed by Autodesk. AutoCAD is another one. 3ds Max is another one, so on and so forth. So if you do come across any challenge regarding Revit that you cannot resolve, make sure you go to this Autodesk forum. You search for your doubt. Most probably, it will be already a doubt or a challenge that has been faced by someone all over the world, because this forum is open to everyone on the world. Only thing, you need to have a valid Autodesk account. Okay, you don't, in case you don't have a paid version, that is fine, of Autodesk product, but you need to have on autodesk.com, you need to have an email ID and password associated with that. You can access this website. You can, if your answer has, if your question or challenge has not been resolved earlier by someone else, then you can go ahead and post it by yourself as well. Okay, till this thing opens, we'll go back to our project now. Now that we have downloaded our first family, we'll take a look where it resides. Okay, so as I mentioned, we require a properties and a project browser menu. All right, over here in the project browser menu, if you scroll down over here, you'll have different trees. You have a views tree. If I click on the negative sign, all the views will basically collapse. You will have the schedules tree over here. You will have the families tree over here. And these are the same families that I was mentioning. Okay, families are the products that you will be mounting in Revit for showing it on the floor plan. Okay, so just like we had the different types of families, when we clicked on load Autodesk family, and we saw a lot many families over here. So this one, just like we had a lot many families over here. I'm not going to go deep into it because we have seen the families on the left hand side over here. So all of those type of families, the library will be over here for the families. Okay, when you click on the plus sign, now we are talking about air terminals. You remember we had went to the air terminal section, searched for a linear slot diffuser. From there we had gotten the linear slot diffuser into our project. So if you click on air terminals over here, you will see all of the air terminals, be it diffusers, grills, registered, that are already in the project. Okay, and the one that we have right now installed or right now loaded is this one, 24 by 3/4 6-inch inlet 2 slot. Does that make sense? All right. Are folks over there able to see it because of this thing? So you are able to see it properly, right? Okay. So now over here, this is the particular diffuser that I have got. Any problem with anyone? Any help needed? On this side, everyone okay? Any help needed? Yes. No, you are using an architectural model. You need to use the model that we have set. Any on the system center. So this is the architectural model. You need something like this. One method. What happened? Did you buy that seat? No. So you have to find that but it's just the ones someone then No, it's there. Now let's go down and
Okay, so everyone will meet now.
all right. So online as well, I assume everyone is with me. No questions. All right. Okay. So what we need to do is there are two ways of mounting these diffusers. One is either you click on this, click, hold, drag. Okay. When you click, hold, drag, you will see something like a no parking sign on the tooltip over here. Okay. Now, the reason being, we'll go back to the image for the linear slot diffuser. My diffuser is not available. Tony, have you gone to the project browser and scroll down where it says air terminal supply diffusers with plenum linear slot hosted? And then you have the option over here. Please check that once and let me know. It is in the project browser. Yes, it is not there. Okay, then you'll need to download it. You need to go to the load family and load it again. Do that once and let's check once. All right. So the reason being, let's take a look at a typical linear slot diffuser. So in this picture, where do you think the linear slot diffuser is located? In the ceiling, right? Now, if we look at our model, we were looking at the section view. Was there any ceiling in there? No, right? Okay. So now this is something that happens on a very regular basis when we are dealing with different parties. Okay. Yesterday we had a good discussion regarding can we use Revit model for energy analysis, right? For energy modeling we were talking about. In an ideal world, the architect will properly model everything to the decimal points. But in real world, what happens is there is project timeline that we had discussed, the DD, CD, construction document, construction administration on the first day. The timeline seldom match. So it is a race to catch up with the other team. All right. So very often this will happen that you may or may not have the fully developed model from the architect. Okay. In that case, I'll teach you what needs to be done. In that case, what we'll do is we'll create a reference plane which will basically act like a ceiling in the given room. All right. Okay. So now what we need to do is let's go to the architecture ribbon over here. Sorry. It does not come even after reloading. If possible, Tony, can you send us snippet? Screenshot can he send?
Yes.
Can you send a screenshot on the chat window? Okay, so let's go ahead and go to the section view on your floor plan over here. Okay, you had any section view. It can be the horizontal or vertical section. So please go to that section view. Click on that section view. Right click. Go to view. Got it? Are we all on the section view right now? Okay. So now go ahead and go to the architectural ribbon. In the architectural ribbon, in the work plane setup over here, you will have something called as a reference plane. Yes? Click on it. You will get a crosshair on your mouse cursor now. Got it? Okay. So what we are going to do is we are going to draw a reference plane, which is, let's say, 1 feet 6 inches from the floor of the level above. So you click, then you draw the reference plane on the other side. Okay. I'll show it again. You go to the architectural tab, click on reference plane over here. You go to the section view. Of course, you should be in the section view. Try to measure 1 feet 6 inches. It will automatically show that 1 feet 6 inch reference from the floor above. Click on it and then drag it to the other point of that room. Got it? Okay. Just a minute, Tony. Yeah. So Tony, I see your screen. In the supply diffuser with plenum, open that plus sign. So I will show it on my screen now. So Tony, if you go to your air terminals over here, I see that you have the supply diffuser with plenum linear slot over here. Click on the plus sign. Once you click on the plus sign, you will see the 24 into 3 1/4 6-inch inlet 2 slot. Okay, so everyone is with me for the reference plane? Yes. All right, so in the room there was a point that just like I was clicking on reference plane over here and it was giving me these reference dimension, someone is not able to see these reference dimensions on their screen. Okay, so for that what we'll do is we'll take an alternate route. We'll draw a reference line for some time. Okay, that reference line is just meant for making sure that our reference plane comes in 1 feet 6 inches below the floor. Okay, for that, yesterday, just like we had used the annotate ribbon for giving text, okay, today we will use it for drawing a detail line. Okay, what is a detail line? It is basically an annotative element. It does not have any 3D form to it. Okay, in case you require to do some reference work, this is a good option. Okay, so in there, annotate ribbon, go to the detail line option, and then in the detail line option, start drawing the line from the top, and then it should show up with the reference lines. Is it showing, sir? It is showing now? Okay, so now click where it shows 1 feet 6 inches, and then you will see this detail line. Okay, it's a detail line. This is just like for any, let's say you're drawing a single line diagram. This comes in very handy when you're doing a single line diagram. Schematics, very handy when it comes to schematics. All right. Okay, now let's go ahead and go to the architecture reference plane. Now we have the reference of this point, that is 1 feet 6 inches below the floor above. And now we have our reference plane. Okay. Everyone with me till now? Okay, so now let's go ahead and name this reference plane, because right now there is no reference plane name assigned to it. Okay, so let's assign the reference plane name as first floor ceiling. All right, first floor ceiling, and hit apply over here. Once you hit apply, that same name will show up over here. And alternately, instead of entering the name over here, you can click on it where it says click to name. Just click on that point and start typing the name of that particular ceiling. Make sense till now? No? Okay. Okay. So everyone with me till now? Reference plane? Okay. Now let's go ahead and do the same thing. Click, go to the level 1. Click, hold, drag. And then over here, it shows you option for placement on top. Click, hold, drag. And then it shows you option for placement over here. Are you able to see it? Click, hold, drag. Click, hold, drag. Okay. Leave it over here. Don't place it. Don't click it over here. On the top, you will have option for placement. Again, one more time. Click, hold, drag. And don't place it. Don't click on anywhere. Just click, hold, drag. And on the top, you have the placement over here. Everyone with me till now? Okay. One more time. So over here in the families in the project browser, you have the supply diffuser. Click, hold, drag. And then don't place it anywhere. You'll see placement option on the ribbon over here. Got it? No? Yes? Any luck? Let me go around. Online folks, if you are facing any issues, please drop your message in the chat box as well. Okay. All right. So yes. Click, hold, drag. Click, hold, drag. And just leave your mouse. Don't click anything. Just leave your mouse. Leave the button. Over here, it is showing you are not. No, it's not the correct one. It's not the correct one. You need to download it. Yeah. Download it. Everyone is need to now. No. No. Now, once in the project Okay, one more time. This over here. Click, hold, drag, and then you will see these placement options. Either it will be directly showing place on vertical face, place on face, or place on work plane. But we need to have these options activated. Okay, one more time. supply diffuser with plenum linear slot. I'm seeing many of you have not downloaded that family. So please make sure you go to that insert ribbon, load Autodesk family. Make sure you have United States Imperial and you download the supply linear slot diffuser, not the any other kind. Okay, please make sure you have the right one that you have installed. I've seen many of you have not done it. Click, hold, drag and leave your mouse button over here for 2 minutes till these three options show up. With me till now? Yes? All right. Now what we'll do is we'll click on place on work plane. Okay. Once you click on place on work plane, you will have options showing up over here. Modify place component, rotate after placement. In the placement levels, drop down this box, you will see the reference plane that we just created. Okay. So just a minute.
After that.
Okay. So we have this dragged over here. In the placement, we will select the place on work plane. Place on work plane. Yes? All right. Work plane. Last option over here. All right. Clicked on that. It will give you options over here. Yes? Okay. So what we are trying to do with this, we are trying to have that linear slot diffuser properly aligned with that reference plane that we just created. That reference plane is symbolizing ceiling. Okay? Make sense? All right. Now, if I move around with the first floor reference plane, that particular linear slot diffuser is properly showing up now. Okay? If I want to rotate it, if I see on the left hand side, there is a small rectangle coming out of that diffuser. That is the inlet of the diffuser. The inlet of the diffuser will come from the plan east, not west. So we need to rotate it. So if you hit space bar, that will rotate your diffuser. Okay? And then you can go ahead and place it. Now this is your first linear slot diffuser that you have placed. If you go to your section, this section, you will even see your linear slot diffuser. Let me check here the terminals on. Yes. Yes. Or is it looking the other way? Okay, yeah, it is there. It is there. It is there. It's upside down, but we'll talk about it. Everyone with me till placing our first diffuser on the floor plan? Yes? Yes? Awesome. Now, we'll take a look at how it is placed in the section view. Why we are doing this? We need to make sure it is properly coordinated now. Right? When we go to this section view, we'll see that the diffuser is upside down. But it cannot be upside down. The air needs to come down over here. Right? For that, you have this flip option over here. Once you click on the flip option, the diffuser will go up. The diffuser, as compared to the ceiling, it was going like this. But we needed to come from the top of the ceiling. Right? For that, we have the flip option over here. Just like we had a flip option for sections, right? Over here, we have a flip option for section. Just like that, we have a flip option for the diffuser that we are working with. Over here. Make sense? So make sure when you're working on a project, have at least two views on. One is the floor plan and the other one is the section view. It will give you a better idea of three-dimensional concept. If you are just looking from it from a floor plan, maybe it might not be coordinated. It might look coordinated on the paper, but it might not actually be coordinated. All right? Yes? Any more help needed? Okay. All right. So now we'll go to the floor plan again and see what happened to our diffuser. When we were flipping the diffuser, that neck of the diffuser over here, that also got rotated. So don't worry, we simply need to hit space and that will rotate by 90 degree. Hit space on your keyboard, it will rotate by 90 degree. Just hit and remove your finger. Don't keep it pressed. All right, just hit and remove your finger from the space. All right, understood? Okay. All right. So now, everyone with me? Only 2-3 guys are with me right now. Online, anyone has any doubts, please share them in the chat box. All right, team, please make sure you put in effort to get this done. At the end of the day, till well before Friday, we'll need to make sure that you have done the entire floor in Revit. So make sure you put in the effort. Okay, again, strongly recommending put in the effort so that you have a copy of an updated floor plan in Revit. Right? Okay, let's move forward now. Any questions till now? Okay, let's move forward with drawing our first duct. Okay, now what we have placed over here is a supply air diffuser. Okay, there will be 4 types of ducts in a given project: supply, return, exhaust, outdoor air. Supply, return, exhaust, outdoor air. Is everyone understanding? 4 types of ducts in a given project: supply, return, exhaust, outside air. Supply air, return air, exhaust air, outside air. Make sense? All right. So what we have in mounted over here is a supply air diffuser. The air that will be coming to this diffuser will be treated air from the central air handling unit. Please remember, we had learned this in the first 2 days. Central air handling unit. Right? Okay, so now we are going to draw a duct. By the way, if the room tag is getting too interference with your work, you can simply click on it once. You will see the move button over there and you can move it around. Okay, please note, once you move this out of the room, sometimes it might give you a question mark over here. In that case, you can simply add a leader like this. If the leader is not visible, click on this, you will have the leader visible over here. What is a leader? It is just a arrow pointing to which room that label is. Okay. Again, this, just like the detail line, room tags are annotative elements. They don't have a 3D form assigned to it. All right. Now that we have the first diffuser, let's go ahead and click on this plus sign. Whenever it is a plus, it is a supply. Okay. So whenever it is a plus, it's a supply. Everyone can see this, right? Whenever you see a symbol like this, it is a supply. Okay? Whenever you see a symbol like this, it is a return. Okay? Whenever you see a symbol like this, the Y is an exhaust. Okay? Outdoor air classifies in this category itself. Supply, return, exhaust. Okay, you will see these symbols again and again in a given typical mechanical project. So make sure you get familiarized with it. It's the supply. You can have the supply, but make sure you tag that duct properly. Okay. All right. So now, just for the folks that are online, I'll give you guys a description as well what I drew over here. I should have done. Get to the folks online. What I described in the room was different types of symbols. When you see a symbol like this, it is for the supplier. When you see a symbol like this, it is for a returner. When you see a symbol like this with the Y, it can be on this side, the Y. It can be either like this, or it can be like this. Same thing. It's an exhaust air stream. Now, Y, X, and just a slash. Many a times, this symbol is also used for outside air. Excuse me. But make sure you have the tag properly assigned to it. Whenever you are drawing tags, make sure you have proper outside air tag assigned to it. All right. We don't want confusion to happen that is this a supplier or a outside air duct. All right. Going back to the presentation. All right. So again, now we don't need the number one. Number one was just for us, for our reference yesterday, since the room tags were not there. So if you delete this number 1, 2, 3, 4, that is fine as well. So I'm going to go ahead and delete it because it is becoming too crowded. Now clicking on that particular diffuser, I click on create duct. There will be an option over here for that same supplier symbol. If I click on it, there will be the supplier duct. Now what you see on my tooltip is the supplier duct, which is 8 feet 6 inches in length. I can remove the length, add the length as needed.
In the 6 inch.
It is a 6-inch diameter duct. Why 6 inch? Because when we were selecting the slot diffuser, we had selected the inlet to be 6 inch. Make sense? Okay. So again, all right. So now if I click over here, it is automatically defaulting my duct size to 6 inch. Why it took 6 inch? Because this neck is supposed to be 6 inch based on the family that we have got into the project. Make sense? So now what we'll do is, we'll take this duct and we'll bring it to the corridor. This is our first supplier duct. Okay. Now we'll go back to our presentation notes where we were talking about the classification of different types of systems for different types of rooms, right? So now we need to select one among this, right? This is the reason why I gave all the background information, because when you are designing the project, you need to make informed decisions. Drawing ducts is one thing, but selecting equipment is another thing. So that time, this slide deck will help you make an educated decision on which type of system you should use.
But that the recommended design is round one. Is there to the way to customize with like transition for round?
Sure, yeah. We can do that. Just a minute. Let me finish this thought, then we'll come to this. Okay. In this case, I'll explain the question as well in one point. But in this case, we are looking at a patient care area. We are given these many options. Now, please note, when you are using one of these options, it cannot happen for one of the area on the same floor in the same building. You are using a constant volume single duct terminal heat. On the other one, you are using constant volume double duct. Okay. At the end of the day, the central air handler is one. So you need to use that central air handler to have proper supply to the all of the rooms on the project. All right. So you cannot afford to have a single duct at one point and double duct at one point. Okay. Is that making sense? Okay. So now for our working, what we are going to do is we are going to go with a VAV reheat. The reason being, I want to teach you the VAV box terminology and how it works. Okay. VAV, when you have a variable air volume, basically your controls are very well defined. Okay. You can modulate your airflow to very low quantity as well as very high quantity based on the load. Right now we have, excuse me, can I have the attention, please? Excuse me. Hello. Can I have attention, please? The reason I'm talking about the VAV ducts over here is because we have done a very extensive exercise of calculating what the heat load is. Okay. Yesterday, I have given you an indication. 1 kg of refrigerant, if it leaks, how big of a trip that kind of equates with, right? So when you have the VAV box, which is modulating your airflow, that is basically tracking your heat loads in the building. Your fan coil unit is sized for 2 kW, 1.94, 2 kW, right? We have upsized it and we have made it 2 kW. Not necessary. In the morning, that room might not need the entire 2 kW of cooling. It might only need 0.5 kW of cooling. At that time, you can use the VAV box to reduce the airflow. Right? Is that making sense? That is the reason why we are doing all of this background thing to come up to informed decisions. We are experienced engineers over here, and these are the informed decisions we are taking based on the background information that I've given you over the last 2 days and right now as well. Make sense? Okay. All. Your question was regarding the transitions, right? Okay. So the question in house was regarding the transition. Right now, it defaulted to a round duct. Let's say we want to have a rectangular duct. Okay. A round duct is maybe not preferred in this room. What do we do in that case? So in that case, we can simply begin with a round duct, and over here we can drop down the box to make it rectangular, oval, whatever duct we need. Right now looks like rectangular duct is there. So if needed, these are the different types of rectangular ducts we have available. Okay. So let's say I have a tap metered elbow rectangular duct that I'm using. I straight away start to draw it, and over here, as you see, now it is width and height that we are talking about, right? Earlier it was diameter that we were talking about. Here it is diameter for the round duct, right? When I changed it to a rectangular duct, it is showing me the width and height. Make sense? Now, if I start drawing it, you'll identify that there is another fitting that Revit itself has assigned to the duct. That is the rectangular to round fitting at 45-degree angle. Make sense? You don't need to go in there and show it like you show it in AutoCAD, that expansion, this and that, that is already done for you. When the contractor is ordering their stuff, what they are going to do is they are going to count these to order it. That way they don't have to go through each and every transition throughout the project to count how many transitions there are. You understand the coordination, the time saving that is coming into picture now? Okay, perfect. Now, we'll take it as a 6x6 inch, that is fine. Now we will take it outside to the corridor. Okay. Similar to what we had done for the air terminal, what I want you guys to do is load the VAV box family. Okay. Similarly, go to the insert. By the way, everyone with me till this duct? Any questions? Is everyone getting it? I can wait for 2-3 minutes more. Yes. Sure.
Can we use flex for that?
Sure. Yes. Good. Yes.
1.5 and we connect the ducts to
Yes, that is a very good. Absolutely. So again, now we are coming into the coordination aspect, and what Mohit said was very good point. When we locate a diffuser in a ceiling, right? The ceiling, it might be 2x2 grid ceiling, right? It might be a chipboard ceiling. If we have a chipboard ceiling, the amount of flexibility where we can place that diffuser, we have more, right? Why we are talking about this? Because this right now that I am showing on the screen over here is a rigid duct. And sorry, for the folks online, there was a suggestion from the team in-house that can we add a flexible duct while connecting to the diffuser. So that is the reason why I'm having this conversation, that in case there is no flexibility of us and this duct now becomes rigid, because this is a rigid duct, this connection is a rigid, so we don't get an option to do any adjustments over here. Okay, so what will end up happening on the field is, I'll delete this one. What will happen on the field is, either you can draw the duct from here, or there is another point over here as well. Right click on it, and then you can draw flex duct. Everyone knows what a flex duct is. It can be flexed around, right? Okay. So draw flex duct. When you start drawing flex duct, it will show up like these lines over here. Okay. Once you can do a spline with it, and once you are done with it, right click and hit cancel. Your flex duct will be drawn over here. Is that making sense till now? You want me to show it again? Yes? All right. So two ways to draw duct out of this diffuser, or any diffuser per se. You will see this connector as well as this connector. This you can directly click and start drawing on it. On this connector over here where you have the neck, right click on it. Your options will show up, and in here you will have draw flex duct. Alright, once you click on it, this particular dash that is coming along with my cursor is your flex duct. So maybe I can click once, click one more time, click one more time, and hit enter to draw my flex duct. Okay, let's draw this flex duct and then we'll move further. Right click, draw flex duct. Have 2 points that you can show it it's a flex duct, and hit enter to end the command. Everyone with me till now? Yes? You guys got the flex ducts? Okay. Yes. Well, customize, you have a round flexible duct. You can make it bigger. No, yeah, you can do that as well. That's fine. I just wanted to show the spline aspect of it. So if needed, what you can do is to mimic to what they had shown. Right click, draw flex duct, and it was something like this going up, right? Something like this was showing up, right? In the image. Is it right? Is it answering your question? Yes, right? Okay. But I'll let you know in a moment why flex duct's length should not be that much. Okay, so everyone done with the flex duct? Yes? All right. So a word of caution over here. Flex duct, try to keep the length maximum. Excuse me, if I can have everyone's attention. Flex duct, try to keep it a maximum 5 feet in length. The reason, maximum 5 feet in length. Length, maximum 5 feet. The reason I'm saying is the pressure drop on the flex duct is a lot more as compared to the pressure drop on a rigid duct. Okay. We were talking about the external static pressure yesterday, right? So when we were talking about rigid duct as the for calculation of the static pressure, we were looking at 0.08 inches per 100 foot. So if you have a 100 foot length duct, only 0.08 inch will be dropped in the duct. But over here, for the length of 5 feet only, it might be somewhere like 0.2 inches or 0.3 inches, depending on the number of bends that there are in the duct. Okay. For that reason, always make sure you limit your flex duct to a maximum of 5 foot. If you have the standards of writing specifications in your or tenders in your market, make sure that is specifically mentioned for the contractor to not exceed 5 feet length of flex duct. Right? Yeah. Basically, we are talking about the fan power. The more pressure drop there is, the bigger the fan, the bigger the motor, the more power that the motor will consume. All right? Yes.
What is the pressure rules for the expansion?
Not the expansion. Right? In general itself, it can be tilted, right? So think about it. You have a garden hose and you bend it. The water on the other side will take so much air. So same thing, we don't know how they are going to install this again. It is going to be in the ceiling. It's not going to be visible. In that case, how do we confirm that the pressure drop is to the minimum? Make sense? Okay, let's move forward. So now after this, again, this flex duct will have another connector. Right click, and this time let's go ahead and just draw a regular duct. You can make it 6 inches for now. Okay. Now what I want you to do is go into the insert load Autodesk family and add VAV boxes in here. Remove the linear on top over here so that all of the families are visible. So everyone has the flex duct. Alright, so what I want you to do is I want you to go into the load Autodesk family window again and try to find the VAV box. Search for VAV box. Is everyone following? Please search for VAV box over here. Again, please pay attention everyone. Insert load Autodesk family and try to find the VAV, variable air volume. VAV. Got it? VAV box. Anything online? No, right? Type in variable. Type in terminal. Type it for terminal. Please note it's terminal, not VAV box, terminal. Has everyone gotten it? Okay. Sorry? Yes. To the participants online, just a minute. I'm having the same issues that some of you guys are having. Okay, so I'm going to share my screen from Gorky's laptop for 2 minutes. Thanks. Duplicate. So, okay, so now I'm coming from Mr. Gorky's system. If I can have everyone's attention, please. Please. So again, we are talking about going into the. It's so visible, right? Gorky's screen. Yeah. Sure. Insert ribbon. Load Autodesk family. Over here, make sure you have you go back to the MEP over here and then scroll down and try to find terminal units over here. One more time in the MEP, scroll down in the airside components, use the terminal units. Everyone with me till now? Okay. All right. So yesterday we spoke about the fan coil units as well. If you need to have a fan coil unit on any of your project, here are the families of it. Okay. I would still suggest you that you work with a vendor to get the custom Revit family for your project. But if it is not there, you can use one of this, but please make sure you consider the clearance spaces. Many of us in the room are into the facilities management team. We know how effortful it happens when there is no space for proper clearance of HVAC, electrical, plumbing equipment. So make sure if you're using one of these equipment from the libraries, they are properly accommodated for the clearance spaces as well. Okay. Now, the thing is, we want a regular VAV box. We don't want a lot of heating going on, so we'll not directly look into heating for now, but we'll have the VAV box properly attached to our given duct. All right. So for that, let's go ahead and add a VAV unit single duct. Okay. Yesterday we spoke about the VAV unit dual duct. Everyone remembers? It's the same concept. Okay. We needed to have that basics to understand why we are using what we are using. We will be using VAV unit single duct. Click on it, load. Once it is loaded, now go back to your project browser. In the families over here, scroll down to the mechanical equipment and scroll down, you will have your VAV unit single duct over here. One more time. I'll show you from the beginning. Please pay attention. Load families. Load Autodesk family. In the Autodesk family, make sure you click on the MEP option over here. Under that, airside components. Under that, terminal units. Under the terminal unit, VAV single duct. With me till now? Okay. Next thing is, in your project browsers, just as you had located the supply diffuser with plenum linear slot, under the air terminals menu, you can scroll down and find mechanical equipment option over here. Click on the plus over here, you will see the VAV unit single duct that you have just loaded into the project. Peter, you mentioned no audio. Is it still true or do you have audio now? Okay, everyone with me till now? Do I need to repeat myself? Okay. All right. So what we will do is, we will go to a website called as Train VAV Box. All right. Everyone has heard about this company, Train, or their collaborator Mitsubishi. Sometimes they do Mitsubishi Train, Carrier Train sometimes. So we will be using one of their systems for sizing the VAV box. Okay, because when you went to Revit, it is giving you different options: 4-inch, 5-inch, 6-inch. Now this is the inlet of the VAV box. What you see over here is the outlet of the VAV box. All right. We'll need to locate the VAV box in the circulation area over here. Okay, in the corridor over here. Make sense? For that, we need to understand how much CFM we are putting in there. All right. Now we are going to come to the minimum total air changes per hour in some time when we were talking about 170. Okay. So now before that, let's go to the VAV boxes over here. The first option for train VAV box. Is everyone with me? Or no? Do you want me to repeat this? You're on the same page? Good. All right. So once, oh man, it's taking much time. I'm going to restart my computer once. Okay. So for the folks online, apologies. This is again the same
VAV box page we are on for train. We are talking about the total air changes per hour from 170 standard. We have taken care of the outdoor air changes per hour minimum, but we need to make sure our VAV box is also sized for the total minimum air changes per hour. That's why we are on this particular website. What we will use is a single duct terminal unit, the same one. Okay, this is what a terminal unit or a VAV box will look like. If you need, you can have heating coil on it. Okay, this is a controls box for controlling a damper that is in the VAV box. Basically, it will be like a butterfly damper which will be modulating to regulate the amount of conditioned air that the VAV box is letting it through. All right. So once we click on that, once we open the web page for this, you will have the sales brochure. I want you to check for the before I go to that point, as you see over here, you have a BIM and selection tool. As I mentioned, if you are using an equipment that is manufactured by a manufacturer, of course, it's going to be manufactured by a manufacturer. In that case, always make sure if you get an access to the BIM models, for not BIM models, Revit families from the manufacturer. It is preferred that you use this one. Okay. If not, you can use the ones that we are using right now. Okay, now we are coming to the section that we want to make sure that our sizes of the VAV boxes are done properly. Now we are looking at the size, the inlet size we were looking over here, right? Remember, inlet size we looked at in Revit model. These are the inlet size: 4 inch, 5 inch, 6 inch, 8 inch, 10 inch, so on and so forth. That is the same size that you're looking over here. Okay. Now, going back to the presentation, can someone tell me, my laptop is not working? Can someone tell me what was the total air change per hour required for a patient room from your notes? 20 something, right? Okay, that's fine. That's fine. We'll assume it to be 20 for now. Patient room, yes. It was somewhere around 20, right? The area of the room was somewhere around 129, right? 129 square foot. Square foot, 120, 128. Okay. 128, correct? 128 square foot. The height was somewhere around 9 feet 10 inches, 9.83. Right? And the air changes per hour that we required were in cubic feet per meter. And we were talking about 20, right? Correct? 20 air changes per hour. Total, not two. Total I'm talking about. Patient room, how much was it? Okay, just let me know. I'm also asking. Minimum, not outdoor air. I'm talking about total. Four. Okay, all right. So, questions on mine? Okay.
responses. Okay. Okay. Peter Lawrence Tawalka, thank you so much. Yes, it is 4 changes per hour. That brings us to 80 to 85 CFM size for our VAV box serving that patient. Is that making sense now? Now this is the total air changes per hour. This also contains that 41 CFM we were talking about for the minimum outdoor. Total is a sum of the minimum outdoor air changes per hour along with the air changes per hour that are required for taking care of the loads. Does that make sense? Sure. All right. Now going back to that sheet that we had over here, we can even take a 4-inch inlet size VAV box to serve that area. Okay. But as an industry standards, 4-inch is seldom used. The minimum size that we can go with is 6-inch. Okay, it is an industry standard. VAV boxes are available. Even if you specify the VAV box with a 4-inch inlet size, it will get ordered at 4-inch, but they will bring a 6-inch duct and attach to it. But that is fine because 6-inch duct can take all the way up till 500 maximum CFM. Make sense? All right. So now we'll go back to Revit. Bring the 6-inch over here. Now this is our VAV box. Again, hitting space is rotating it, right? Now over here you might see the offset from host is 0 feet. Okay, that means above finished floor, how much it is? It is on the finished floor because it is 0 feet. We need it to be up in the ceiling, correct? So we need to raise it up. Now if I'll do one thing, I'll place it over here and then we will go to the section view and then we'll try to see where the VAV box is. Oh, there is no VAV box. Where did it go? Okay, let me teach you one more tool that is called the 3D section. For some reason, I'm not able to identify the VAV box from both of the sections. Okay, I'm not sure why this is. Okay, the extent of the section is very small over here, you see. So if I pull that section, that section to include the VAV box, it will be shown on this section as well. Okay, but I want to show you one more trick on how to make 3D views visible. For that, we need to make sure the elements that we have drawn are selected. Okay, click, hold, drag, and select those elements. Okay, once that is done, what I want you to do is go to the view tab. In the view tab, you will have the selection box. Okay, what that will do is it will give me a view in the 3D format. Okay. Okay, I'll repeat it again. This is one more tool that you can use in Revit. The elements that you want to view in 3D view, click in a blank space, click, hold, drag. That will select all of the elements. Click, hold, drag. Don't directly click on this element and drag it because that will move its position. In a location that is not inside, click, hold, drag, and then it will get selected. Got it till now? Again, one more time. You want me to show one more time? All right. So again, select an area that is not directly on the top of the element, somewhere outside. Click your left mouse button, hold, drag to select those elements. Done with this? Okay. After that, you will see view option over here. In the view option, you will have the selection box over here. View selection box. Try to identify this particular symbol. Every screen resolution is different, so you might be seeing this selection box right away over there. Got it? Click, hold, drag. Selection box will give you a good view of 3D cut section of what you have drawn till now. Okay, this is that VAV box. This is that particular flex duct. As I said, try to keep the flex duct less than 5 feet so that your pressure drops are reduced as much as possible. Yes. Right, everyone with me now? Everyone understood selection box option? Any help needed? Please call me to your desk if any help needed. Online, if you need any help, please put it in the chat box. Because I'm just right now. All right, everyone with me till now? Yes, good. All right. So now that we have seen that our VAV box that we have mounted has gone to 0 feet, right? We will try to raise it from the host. The host over here is level 1. This is the same level, by the way, that we had copied and monitored. Okay. This is the reason why we copy and monitor grids. And level. We had monitored this level yesterday. Now it is being used. Now we raise it. Okay. Once I hit 9 feet, you see the VAV box has gone to the ceiling. Sorry. Offset from host 9 feet. So above the level 1, it is 9 feet now. Okay. I'll show it one more time. Select the VAV box. Once you select the VAV box, in the properties where you have offset from host, the host in this case is level 1. Type in 9 feet and hit enter. Your VAV box will now go in the ceiling space. Got it? How about you guys back over there? Got it? Yes, you guys need any help? You sure? Your laptop is also not on. I would recommend I think taking the effort because we will need to do that entire floor by Friday. So that's why we are pushing you to come tomorrow as well. I need to make sure I clear out all of your doubts before we conclude the session. So that's why please take the effort to have all the modeling done as much as possible. I'm here to help you, I'm here to wait, but please make sure you put in effort as well. Okay, can we move further from this point? Can we move further? Yes. Mohit, can you take a look over there as well? Are they those folks over there? Online, if everyone is following up, if I can please get some feedback. Now that we have located the VAV box, just imagine if the VAV box is in the room. The VAV box, the air passing through the VAV box will always be coming across that damper, right? So think about the noise that it will be creating. Correct? As the air flows over the obstruction, it will make a lot of noise. So it is not desirable to have the VAV box in the patient room itself. That is why we will put it outside the patient room in the corridor where the noise issues are not that big. Alright, so we'll simply click, drag and move it, or if you don't want to do that, click on the VAV box, go into the modify option over here. If it is not visible, there will be two right facing arrows on top over here. Click on modify, and over here you will have option to modify and move that mechanical element. So you can move it to your desired location. Again, this is a 6-inch inlet and this is 10 inch by 8 inch outlet. Okay. Our duct is over here. All right. So we need to make sure that our duct, this will be the basically outlet point connection of the VAV box. So what we need to do is we need to rotate our VAV box. For rotating the VAV box, hit space. Once you have connected the VAV box to a duct, just for example, I'm connecting to a duct. Once you have done that, if you click on the mechanical equipment or any other equipment and hit space, it will not work. It will only work when it is standalone. Like this one is standalone, it is not connected to anything. You can rotate it. Make sense? Once you add a duct to it, it will get locked. It cannot get rotated. It can move around, but hitting space will not rotate it. Make sense? So now what we'll do is we'll align our outlet, the 10 by 8 outlet, to the duct over here. Okay. So if you hover around, Revit will automatically try to snap to the center of that particular duct over there. Make sense? Now you see that center dark line that shows up over here when I try to move the VAV box. So it by itself will try to align the center, at least the horizontal center. We'll talk about the vertical height center, but at least the horizontal center, it has aligned itself to it. Here comes the point for chord. Now, as I was saying, whenever working in Revit, have minimum 2 views on floor plan and section. If you want to have more views on, that is fine. Section, horizontal, vertical, the 3D selection box that I have shown, use that as well. Why we are using that? Let's go to this section view and try to see what is going on over here. The thing is, the duct is over here. I'll talk about why the duct is showing as one line only. But our VA box is on top over here. The alignment. All right, so I'll share my screen again. For the folks online, I was mentioning when we come into the floor plan, Revit, if you try to move stuff around, it will try to auto align itself when you are moving stuff around. Okay. Now, right now, this VAV box center line in horizontal axis is aligned with this center line of the duct. But as I was saying, two view windows or views, one plan view and one section view turned on for coordination will be very beneficial. All right. The reason we'll take a look over here, we'll go to this section view, and now over here you see this is our VAV box and this is the duct that we were talking about. All right. Now this is something of a basic. So as I was mentioning, I would recommend the basic course for from Nziza Training Academy as well. Make sure you have Okay, I'm going to share my screen again. I was mentioning in the house for the folks online, while coming to the section view, we see that the VMP box and the duct are not aligned. That is why we need to have minimum two views, floor plan as well as section view turned on, so that you can do this kind of coordination, so that once our model, if it goes to the contractor and then they are using for coordination, it is properly coordinated at our location itself. All right. So now the reason the ducts are just showing single line is because the view detail is set to coarse currently. Once we click to fine, okay, once we click this coarse, the view detail to fine, you will see the duct showing in two line diagram. Yes. Yeah. Okay. So now that we have the duct shown over here, we will align it with the center of this duct. Please pay attention over here. The center of the duct with the center of the VAV box, we will align it. For using that, we will use the align tool. Please pay attention over here. In the modify ribbon, you will have the align tool. Okay. Click on the align tool. It will ask you for the first reference point that needs as a reference point. Okay. This is our reference point and we are aligning our VAV box to that reference line over here. Is that making sense till now? You want me to repeat it again? Okay. So we see there is clear mismatch between the elevation of the VAV box and the duct, correct? If we try to connect it, it's not going to connect properly, right? So either we need to get our duct up or we need to get our VAV box down. right? In this case, what we'll keep is we'll keep our duct at the same place and we'll bring down our VAV box so that it can be connected. When we are looking at it from the floor plan, it is properly coordinated for that center line, right? Now over here, I'm going to align it. This is the option of align. Click on the center point over here and click on the center point over here. Now the VAV box and the duct are aligned. Make sense? All right. Let's move forward. Now going back to the floor plan. Now you see it is aligned horizontally as well as height-wise. What we can do is simply click, drag, and once you see this round icon over here, leave it so that it can be connected to the VAV box. All right, I'll show it again. Click on this duct. You have the connector over here, the open connector. Click, drag, and then get it to the center point of that VAV box. Leave it, it will get connected to the VAV box. Now what is happening is the air coming from the VAV box is going into the terminal here, to the diffuser in this way. This is the inlet, this is the outlet of the VAV box. Make sense? All right. Can we move forward with this point? Any questions? Online, any questions? Okay. All right. Now we have connected our terminal, the air terminal diffuser to a flex duct. Flex duct is connected to a rigid duct. Rigid duct is connected to a VAV box. Just like that, one by one, we are going to go backwards all the way up to the central air handler that we discussed first day and second day. Is that making sense? For that, we require that E20 spreadsheet. For each and every room that we are using, we require that E20 spreadsheet so that all of this calculation can be done. Is that making sense? Yes. Okay, so okay, so is everything now converging to a point? The reason why we were trying to put in so much effort into all of that basic theory, air changes per hour, everything is making sense now? This is what makes an engineer. All of these experiences. Of course, I could have started first day drawing ducts and showing you diffusers, but you would have not understood where that CFF comes from, why it comes from, what is the temperature we require. So the background came in from. Make sense now? Yes. But please understand, if I can have quick attention, we need to complete the level 1. And when I say we need to complete level 1, we are talking about HVAC, we are talking about electrical, and we are talking about plumbing. Tomorrow when you come in the morning, the team will be guiding you for HVAC. Okay. Tomorrow in the evening, we'll talk about electrical and plumbing as well. Okay. I need to make sure you guys understand regarding the circuiting, regarding the type of outlets that you require for electrical in Revit, in hospital projects in general. In not miss even a single one. So I would recommend, I know you're going back home late, but recommend that you put in time to at least do load calculations, have the VAV boxes selected, have the CFM selected. I have given you all the tools. So I would request strongly that you do some homework. Going back to the school now, you do some homework before coming the next week. All right. And again, I'm not going to be here with a cane because we are not, we are professionals, right? So please, it's a recommendation and a request. Please invest This is investment in yourself. It is not investment in your company at the end of the day. It's investment in yourself as engineers. So put in the effort. All right. Make sure you save the model. We are going to use the same model tomorrow. Make sure you save it. A lot of folks did not save it yesterday, so they had to start from scratch. We don't want to do that again and again, right? We are getting better now. We have gotten 1 inch better now. We get 6 inch, then 10 so on and so forth. But we need to have an upward step. Yes, sir. Sure. Yes, yes. I'll share it. Thank you. So online as well. Thank you so much. I will hand it over to Emmanuel.
So engineers, thank you for your today's active and participation. See you tomorrow. I think what hanyuma